talk a little bit about permutation. A permutation is a way that we can count discrete objects. And we use permutations to count objects when the order in which the objects appear matters. The examples that we used in class were, say for instance, a license plate number. If you lived in a state that allows 6 characters in your license plate, how many different unique patterns of license plates can that state expect to have, given the fact that it's made up of 6 characters? We also talked about passwords. If you work for a company that requires 5 digits or 5 characters in your password, how many different distinct passwords can we expect to have? In order to determine what this number is, we're going to use permutations because the order in which the characters appear in a password matter. Let me give you an example. If I have a 5-digit password and my password is ABC12, and I have a second password which is BAC12, you can recognize that those would be 2 different distinct passwords because the order in which the characters appear makes a difference. And when order matters, we use permutation. So let's say, for instance, that you buy up a plot of land and you want to build some houses on it. And you're going to build some houses that line Main Street. And so you as the developer get to decide what the addresses are of each one of these individual houses. And let's say that you decide that you want to have each house number can be 4 digits long. And so you want to ask yourselves, in theory, how many houses can I build if each one of the house numbers are 4 digits long? So when I began to decide how many house numbers that I can have, I would have to ask myself the question, does 1215 North Main, would that be the same address as 1525 North Main? And the obvious answer would be no, those are not the same. And so the order in which the characters appear matters. So I'm going to use permutations. So what I'm going to do is I'm going to write down spaces for the 4 characters in each one of the house numbers. And I'm going to decide how many characters can I have in this first position here. Well, if every house number has to be a digit, a number, there's only 10. The numbers 0 through 9 are the only thing that I could put there. In my second space, I could have 10. And in my third space, I can have 10. And in my fourth space, I can have 10. So each one of the digits in my house number can be one of 10 values. And so if I multiply all these together, and I'm going to multiply them together because it has to be 4 digits long, which means that I have to have a first place, and I have to have a second place, and I have to have a third and a fourth character. So this is going to end up being 10 raised to the power of 4. I'm going to multiply them together because I'm going to use the word 10. I need a first digit, and I need a second digit, and I need a third digit, and I need a fourth digit. And this AND operator to me is going to indicate multiplication. That's why I'm going to multiply the 10s together. And so I can see that if there is a formula that I would use to count up permutations when order matters, I would use the formula n raised to the power of r, where n is the population and r equals the number of elements that I am choosing. So the formula that we've come up with for permutations has one caveat. The fact that when I choose an element out of when I choose a digit, let's say for the first character I choose a digit 0 through 10 or 0 through 9, and then I choose a digit for my second character 0 through 9. When I choose this first digit, like let's say for instance that I choose a 1 for the first digit, I can actually choose the 1 again for the second digit. In theory, I could even choose it for all digits, which means that I could have the address 1111 North Main Street. I could have the address 2233 North Main Street because choosing an element out of the population does not remove it from the population. So I can have repeating elements. So this particular formula is going to be specific to a permutation when I can have repeating values. So this formula is going to be very specific when I can have repeating elements. When selecting an element out of the population does not remove it from the population. Next, we're going to talk about a permutation where order matters. When selecting an element out of the population does remove it from the population, it's going to change my formula just a little bit.